Hey everybody, we are on to mini lecture number 4 out of 5 in this week 2 of Geography 4880. And in this mini lecture, we will be covering the rise of economic and urban geography, or spatial science, actually, during the 1950s and 60s. We'll come to know this period as the quantitative revolution in geography, in which geographers came to react very strongly against the regional geography focus on describing particular places as unique entities, and instead came to offer a model in which geography sought to measure processes in order to explain them and make predictions that could be useful for policymakers, companies, military, so on and so forth. So this subfield in geography, which really did come to be the most important part of geography at this point in time, emerged in the 1950s, strongly influenced by neoclassical economics that was taking root widely in academia and society at the time. We'll say more about what neoclassical economics is in just a second. As well, it was influenced by the demand for science-based decision-making that emerged after World War II and in response to the need for rationally planning national healthcare systems and everything else that was promised to people after the war. And it was a reaction to regional geography, or geography as exceptionalist. Okay, so in other words, the idea that geography was an exception amongst the sciences because space was a fundamental concept for human beings. Okay, actually, economic and urban geographers, spatial scientists at this time said, no, there's nothing exceptional about geography. There's nothing exceptional about space. Space is important. We should study it, but it doesn't, that's not what makes geography, a science. It's not that space is such a fundamental, concept to human thinking, as philosophers like Kant said. That's not the case. Indeed, what makes geography a science, the spatial scientist said, was simply that we treat our subjects in line with the positivist way of thinking. That is, we start from empirical facts that can be observed through our experiences, that are objective, that is not tainted by our subjective, personal opinions and biases. And we build up theory from that, theory that can be generalized and applicable anywhere in the world. That is what makes geography a science. The spatial scientists at this time argued against regional geography. Indeed, they also argued that geography should not be an ideographic kind of a discipline or field. That is to say, it shouldn't be something that is interested in writing about particular places. Instead, they said geography should be nomothetic, okay, which is basically Greek for more systematic. So, in sum, spatial science was a move away from that fixation on the particular and toward the making of claims that could be more generally applied. The refocus, it was a refocus away from fixed things. Remember, regions as sort of thing-like entities that existed across the earth, and towards more dynamic processes. So spatial scientists said, areal differentiation? Nah, areal integration. So how is it that processes connect different parts of the world? That's what we're interested in, they said, rather than simply describing how Southern Ontario is different from the US Midwest, is different from the US South. And, as part of this refocus away from fixed things and just describing them towards looking at more dynamic processes, they emphasize the necessity of measurement. Okay, so this harkens back to the other side of the coin that we've looked at over millennia in geography, general geography, that kind of geography that's rooted in a focus on measurement of the earth, okay, in developing coordinate systems and measuring distances between places, okay. that was really kind of where the emphasis in geography churned at this point in time. Again, we're talking the 50s, 60s, in the 70s here. All right. So within economic and urban geography at this time, the key assumption was rooted in neoclassical economics, as we said previously, which essentially said humans are rational economic actors, homo economicus. The way that we think is we prioritize minimizing costs to ourselves, and that ultimately bubbles up into societies and markets and market actors like corporations minimizing costs to themselves. And that's our core starting point, economic and urban geographers said at this time. And we can bring that into account when we look at space. Space can be modeled and future economic activity predicted to inform economic planning through quantitative calculations. Okay, so this was very much, going back to our conversations about the philosophy of science last week, this is very much a positivist kind of attitude and approach to what valid knowledge is. Valid knowledge is that which can be objectively measured, distances between places, and amounts of things produced, and amount of money spent, things like that. Amount of time traveled in a car. Okay, from that we can then make some assumptions about how people act, model that, make predictions, develop general theories about how societies develop, how cities expand, so on and so forth. So as an example, of the kinds of things that were emerging at this time, well, distance could be a predictor of firm behavior. Okay, so let's think about economics in terms of space. Well, a firm might want to find themselves at the middle of the market in the two raw materials it needs or works with in order to send widgets to the market. All right, so we can model that out in diagrams like this and maps like this. Okay. Economic geographers were also influenced by von Thunen's notion of how settlements formed in relation to space. This is actually an idea of what we're seeing here from the early 1800s, but spatial scientists got a hold of it at this time, the 1950s and 60s, in order to inform their own models of how cities and regions developed. Okay, so their theory was based on von Thunen that distance could help us predict market patterns as a whole and settlement patterns as a whole. So the things that don't often go to market and that are expensive to transport to market, they're going to be on the fringes. So things like livestock, you only take them into market once a year or so, and they're really hard to get there. Whereas dairy farming, you got to take the milk in every day, and it's really costly to move milk because it's liquid. And so it's going to be really close to market, as well as, market vegetables, market gardening. That's going to be even closer because that fresh produce needs to be closer to the market. And indeed, urban geographers got a hold of this at the time to think not just about, agricultural societies, but indeed, manufacturing, residential areas, okay? Where warehouses go, where high-end retail end services go, and how that's going to be shaped by land rent patterns. Okay, so rent is going to be more expensive in the inner core. Okay, so you're going to see certain entities show up out there. The financial corporations that can pay that rent, so on and so forth. So in this way, distance is a predictor of cost, and cost ultimately is a predictor of urban form and landscapes. Notice what we're seeing here are models, okay, not actual cities, nor not these models actually applied to actual cities. Okay, so geographers at the time were really interested in developing these theoretical models, okay, to explain in very general terms how a space unfolds. And whether those models actually matched reality is another question, okay? So what we see in a lot of these models where distance is a predictor of cost is what that sort of bubbles up to, or bubbled up into in the 1950s and 60s, is it's an emphasis on what's known as central place theory. So it takes this German geographer Kristallers ideas about these hexagonal patterns of markets and towns and cities, and sort of a hierarchy of nested hexagons that describe the relationship between small markets, bigger towns, and even bigger cities. Geographers took this theory and ran with it in trying to understand economic and urban patterns. Okay, these kinds of theories require, just as any kind of theory requires, certain assumptions. Okay, your textbook spells out some of them, but just take a look at this and think to yourself, well, what kind of assumptions do I have to make in order to think in order to see the world and understand the world working in this way? Well, I have to assume that, I have a kind of even playing field, an isotropic plane, where space is kind of flat. Okay, there's no mountains in the way that might shape, transport between towns and markets and cities. There's no rivers in the way even. Okay, I have to assume everybody is just out to minimize their costs and to maximize the amount of profit they can make on the things they're selling. Okay, I have to make assumptions in order to make this theory work. Now, really at the core of things that urban and economic geographers were doing in spatial science at the time was the notion of mobility. Okay, remember that during this period, okay, the quantitative revolution, where we turn from the regional geography's focus on describing in qualitative terms what's going on in the place, to measuring in quantitative numerical terms what's going on. We're concerned with processes and movements, okay, in measuring those. And that emphasis on movements was, for some, like Bill Bungay, really key. Indeed, he thought it could actually link human and physical geography together, because, even mountains move. They move very slowly over time, but even mountains or tectonic plates, they move. So, this also showed up in things like central place theory, because it's the cost of movement, whether it's getting goods to market or going to market to buy them, that is really what shapes those models' results. Indeed, it was movement as the outcome of rational choices involving the comparison of one location with another that was the fundamental assumption made at this time. So by now, you're probably thinking, well, central place theory, I have some questions about it, okay? And indeed, so did many other geographers writing at the time of the quantitative revolution in geography. So take something like this, and here we start to throw in some complications to the model. We have a river, there's a sub-center or some other sort of town that isn't matching the pattern that we would expect from the development of different areas, according to von Thun and Kristallers' model. Okay, and indeed, those real kinds of considerations, physical geography, in terms of topography, mountains, rivers, so on and so forth, were a real limitation to fitting these models to actual places in order to use them to predict how those actual places might expand over time. Okay, and geographers also began to note, well, what about, maybe we're not asking the right questions here. Some geographers begin to think, well, it's not just, how far does it take someone to get from point A to point B, and are they really trying to minimize their cost in terms of time or gas from getting from point A to point B? It's also maybe about the experience of getting from point A to point B. What does it mean for somebody to be commuting, every day? What is that experience like? And how is that experience structured by different factors? Okay. And indeed, what might housing patterns or the development of a city as a whole, how might that actually be structured by different considerations and not just, cost in terms of space? So for instance, urban spaces are full of these differentiated experiences, differentiated experiences of housing. We have good housing and we have poor housing, not just some sort of concentric circle of housing, okay? And that is certainly something that people think about, in their everyday lives, the quality of the housing and access to housing. Obviously, urban spaces are differentiated in terms of workplaces and wages. We have high wealth workplaces and high income jobs, as well as areas where there are the low income services and low wage jobs. Costs of living vary even throughout a city. Education opportunities can vary within urban spaces. Access to services and necessities also are differentiated within these. So cities are not, in short, flat, even spaces that we can model so simply. And this is something that geographers really started to pick up in the 1970s. And it was due to a rise in one of these philosophies of science that we saw last week. And we'll pick up in our fifth and final mini lecture of the week in just a second, where we'll get at that.